in theory, if you're on this module, you've already done some web programming. You've got some experience of some server-side scripting. You've got some experience of some client-side scripting. So you might have some PHP or Python experience, or Perl if you're really old. You've got some JavaScript experience. Okay, that's the assumption we're making because we did that last year in 305. And you can build web pages, HTML3, HTML5, CSS3, and so on. Okay, is that a safe assumption to make, that you're comfortable with web technologies? Now, this particular module is divided into 4 sections, and each section has a piece of coursework. And we're going to start this module with web service development. So last year you probably worked on HTML and CSS and built some web pages. This year we're going to completely change the way we develop websites. And I did warn you about this last year. I said it would be very, very different. What we're going to be doing in the first 6 weeks of this module is building a web service API. Just like Facebook has an API, so it allows you to embed Facebook in your applications. Just like Twitter has an API, YouTube, Vimeo, so you can embed things in other websites. We're going to build our own web service API on this module. And that's what we're going to do in the first 6 weeks. So we're going to get going to a flying start on this. And by the end of November, you will have a fully functional, secure web service API. Gentlemen, I start at 9 o'clock, okay, on the dot. So please make sure you're here early next time. So, first thing we're going to talk about is web services, and we're going to build a web service API. So you're going to have a system where it delivers JSON data or XML data with a secure layer to it, and we're going to use that in the second 6 weeks to build a jQuery mobile client. So we're going to build a client which works as client using HTML, CSS, okay, are we ready? Ready to start? Okay, 9 o'clock on the dot, we start this lecture. Do not be late. So in the second 6 weeks, we're going to work in jQuery mobile, and we're going to build a client, a mobile client for our web service. So it'll work on smartphones, tablets, and so on. It'll have an adaptive interface, so if you turn your tablet around, it'll rearrange the columns and give you extra information. And we're going to develop this, and we're going to do what we call web mashups on that. So you're going to be integrating things like Google Maps into it, Twitter into it, Facebook into your So that one will finish just after Christmas. So I think you've got a week back after Christmas to finish things off, and that second assignment's due in. And that's half your grade finished. We're then going to start building our web servers. We're going to use the Raspberry Pis, and we're going to build and develop web servers, database servers, email servers, file servers, and integrate them all together. And then the final 6 weeks, we're going to work with Amazon Web Services. We're going to work with S3, EC2, Amazon DB, and we're going to build our web service using the Amazon Web Services provided. Okay? And this curriculum has been based on experience I've had with external projects, applied research projects. This is the sort of skills that employers really want you to have. Anyone here doing 387com, smartphone development? If you're doing 387com, you've got an extra bonus because your second and fourth assignments in 387 are to build an iPhone client for your web service and an Android client for your web service. Okay, so you get a bonus on that one, extra bonus levels for if you're doing 387com. So let's make a start. Okay, we're going to be recording this. I'm actually dual recording this. We've got, in theory, the Echo 360 system set up, and it should be recording this lecture anyway. The downside of the Echo 360, it's based on Flash. So if you've got a tablet or a phone, you will not be able to watch the lecture on Echo 360 because it just will not work. So just for you guys, I've got another camera set up, and I've got a microphone, and I'm recording the lecture separately. And the idea is I shall substitute the lecture slides that are currently on Moodle with the lecture video as soon as I've edited it tonight. So you'll have access to this video to watch anytime you want. Okay, so the whole point of what we're doing is we're working in the way that modern technology works, the way that almost all software works nowadays. Long gone are the days where you had an application like Word or anything else which just sat there on your computer. Nowadays, almost every app you have on your phone and lots of apps you have on your computer always talk to a server. There's constant communication to and from the server. And the important thing here is that you're going to be developing that bit on the right, and then you're going to be developing the bit on the left. So we're going to develop the whole system in this module. Later on, you're going to develop new versions of this. I say with Amazon services, you're going to build your own servers to host this. And always, you've got to think about this loop, about this communication between the client and the server, because that's how modern software works. Okay. So what are the benefits? Why do we bother having servers? Why are our smartphones constantly using our bandwidth and our data allowance? Okay, I've had students walk in every 2 minutes since I've been talking, since this lecture started at 9 o'clock. I will not tolerate people turning up late to this lecture. Okay, it puts me off my thread, I forget where I've got to, it disturbs people already in the lectures. Do not be late, right? Next week. Okay, so let's get back to what we're talking about. So why do we bother with having this server communication? I mean, the downsides are you've got to have a connection on your phone, it's using your bandwidth, it's using your data allowance each month. So why do all these apps rely on your data connection? Well, the first thing is common business logic. If you think about it, if you're developing an iPhone app and an Android app and a jQuery mobile web app, if you put all the logic and business logic inside the app, you've got to write it in JavaScript, you've then got to write it in Objective-C, you've then got to rewrite it in Java. If you're Windows Phone, you've got to use C#. So you're rewriting the same logic over and over again. So by putting the logic on the server, you can write it once, and then every client can talk to the same server and access the same business logic. Another benefit is sign-in, authentication. It means you've got one single location for all your users to sign into, regardless of what platform they're using, where they are. And it allows interaction between users, doesn't it? It allows you to have sort of social media integration. It allows you to share information between your friends. And if you think about the first 2 points, if your logic is on the server, what are you actually building in your app, in your client app? What's in there? Interface. Just the interface. So all you've got to do is implement a new interface for each of your clients. Please, when you sit down, the chairs bang, they rattle. Yeah, get in here, sit down so I can carry on. Okay, so how do we manage all these interactions? Because we built websites last year, or some of us did. When we built websites last year, they were human readable, weren't they? They were websites which humans could interact with. There were buttons for people to click on, there was paragraphs and headings and all this information in HTML. But this isn't going to work when we're working with our web service, is it? Because the web service isn't a human reading the page, it's a machine. So we have a new technology, a new terminology which we call machine readable web. And if you come away with nothing else this session, that's what you should remember from this session. We are now dealing not with the human readable web, but with the machine readable web. Okay, it's a complete change. You're going to build a machine to interpret this information and turn it into a human readable format. But the information as it comes off the web service is not human readable, unless you're a geek and know XML and JSON formats. Okay, so most of us cannot understand machine readable web data. Okay, so now we come on to the key terminology that's completely transformed the machine readable web. So, we're going to talk today about something called REST, Representational State Transfer. It's taken the internet by storm. It's been out for about, it's been defined for about 12 years now. And in the last 3 or 4 years, it's really taken over. It's so taken over that Microsoft are dropping their own technologies now to implement it. Latest version of .NET, they've abandoned SOAP and all these complicated old-fashioned ones, and they're embracing REST. And the idea is, when we're talking to the servers, we're interacting with stuff, okay, in the technical sense. Stuff. It could be photos, videos, it could be Word documents, it could be PowerPoint presentations, it could be HTML documents, it could be anything, audio files, it's stuff. And when we talk about stuff, when we're talking human to human, we have nouns. In other words, what are we talking about? We have to define what it is we want to talk about. And we have a verb. What do we want to do with it? So by having these, so by having nouns and verbs, we can relatively effectively communicate what we were talking about, can't we? Yeah? Open the door, write on a piece of paper. Yeah? Verbs and nouns together. So when we develop RESTful web services, we define these. Yeah, 2 minutes later. I think we may need to fill in this side a bit because I think the whole lecture is starting to slope. We need to distribute the weight a bit better. If I wait long enough, the next lot will come through the door. There we are. Ladies and gentlemen, when I started this lecture, there were 17 people here at 9 o'clock this morning. 17. Almost everyone in this room is late to the session. Now, late means I lose where we've got to, we run out of time, we'll overrun, we won't cover what we need to cover, and it upsets and disturbs people who are already here. So can please, now you know where the room is, can you make sure you're here next week on time, if not before? Right? You can let yourselves in, that's fine, the door unlocks you with your ID cards, but please make sure you turn up on time next week. Okay? Because I'm not prepared to put up with this. Interacting with stuff. Where did we get to? Oh yes, polymorphic. What does polymorphic mean? Object-oriented programming terminology. It's actually English as well, but well, technically Greek, I suppose. Okay, even if you don't know what it means, look at the words polymorphic. So what do you think poly means? Many, absolutely, many. Morphic? Forms. Yeah, many forms. Polymorphic means many forms. And when we take a noun and a verb, we have to look at them in an appropriate manner. Okay, comfortable? Okay, so let's look at the example of how we use polymorphism in English. Okay, what's the noun? A noun in the first example. What's the person there? Well, can we get into job descriptions here? Waitress. Tennis player. What's the verb? Right, that's polymorphism. That's a polymorphic example. Yeah? It's the same verb, but the noun puts it in context. So we can use the same verbs over and over again in our web service as long as we define the noun that we're talking about. And in different noun contexts, the verbs mean different things. So the idea of a polymorphic speech is that you can use the same verbs and even sometimes the same nouns in different contexts, and they mean different things. So we'll get back to computers in a minute. Don't panic. Important thing is, does that make sense? Do you understand how verbs and nouns interact with each other and how we can be using them in polymorphic terms? Excellent. Right. We have a problem. In theory, we should be able to apply this to programs, to our software that we write. The problem is, yeah, nouns are objects, aren't they, for object-oriented programming? There might be variables in procedural programming. But every language has its own approach. Some languages use objects most of the time, some use procedures. So we have this problem there, but there's a lack of consistency. Verbs, functions and methods of verbs, aren't they? They're actions that you do on objects. But again, every single language does it differently. Every language has its own way of doing things. And what we want is a system that understands the same concepts, but is completely cross-platform. So we've got effectively a programming language that we can use on any platform, using any client. Okay, that's what we're aiming for here. Now, the first attempt at this was something called, well, it was SOAP. It was a system whereby you had methods and objects represented in XML. So you actually took a whole object-oriented approach. This is SOAP. It's called an RPC, Remote Procedure Call. This is another terminology you'll come across. Where you took all the object-oriented concepts and translated them into an XML-based system, where you called methods using XML and you got the response data back as XML. And that's what SOAP was. You effectively translated programming concepts directly into web. Okay, so that was the first attempt, and it was rubbish. Because the problem was, that's not how the internet works, is it? You don't call functions across the internet. You don't have objects across the internet. What you have is this amazing thing called HTTP. This protocol which allows communication across the internet. And what SOAP did, it superimposed its own concepts on top of HTTP. So it pretty much ignored all the useful HTTP stuff and just bunged its own technologies on top. Its own protocols, its own formats, everything was different. Okay, so let's look at some really important ideas here for machine-readable web. A web URL uniquely identifies any object on the internet, doesn't it? You can identify anything on the internet using the URL, whether it's a WAV file, whether it's a PDF document, whether it's a web page, whether it's a CSS file, whether it's a CSV file. Agreed? And no two resources can have the same URL. Yes? Can the same resource have two URLs? Yes, it can. But every URL points to a unique resource, doesn't it? It points to a different resource. So there's our nouns. We can identify anything on the internet using the URL. Okay? So if we can identify a web page using the URL, why can't we identify an object, a thing, using the URL? And we can. Now, we don't call them URLs because Uniform Resource Locator implies it's a physical thing on the system somewhere. We substitute URI for URL nowadays, okay, when we're talking about machine-readable web. Uniform Resource Indicator, okay? Because it could just be some data on the database, couldn't it? It could be anything you want. So the important thing, this guy called Roy Fielding came up with this fantastic idea. Rather than trying to reinvent things, let's work with HTTP rather than against it. Let's use the HTTP rather than trying to shove something on top of it to do what we want to do. So do you understand that important idea? We have nouns in our system already. We've got URIs. So concept of URI. Okay, a URL denotes a resource on the internet. A URI, here's a URI. See, it's different. Subtly different. So tell me, what does that URI identify? What specific thing? Can you work it out just by looking at it? Yeah, there you go, look. Example, bookshop, book. So there's our noun. ID 2, 42. So we've identified a unique resource, and that could be a record, couldn't it, in the database? So we've suddenly got a brilliant way of identifying resources. And what's really amazing about this is if you do them properly, they're human readable. You can work out what they mean just by looking at them. Just like with a method in your programming, if you write the name of the method well, it makes sense to the person using it. Okay, but he didn't stop there. Okay, no, he carried on. Okay, we need a way to describe verbs, don't we? We've got nouns, we now need verbs. We need to describe the verbs in our system. Well, I don't know whether you know about the HTTP protocol, but when you retrieve a web page, you use a get method. And there's post, put, update, head, all these different built-in methods in HTTP. So if I were to look at a web page, okay, and I want to retrieve a web page, I have to send a header information to the web server. And the information I specify is as follows. This is, your web browser sends this on your behalf. So, and we'll show you in the lab this week how to see this information. So first of all, we specify our method, get. And most of the time on the web browser, and using your web browser, it's getting, isn't it? It's retrieving resources, web pages off the internet. Then we specify the protocol, and we're currently on HTTP 1.1. So we specify the protocol we're using so the web server knows what language we're talking. Then we specify the host, the server, and then we specify the URI that we want. So we've got method and URI, we've got verb, and we've got noun. And that's the resource, and that's the verb. And the only 4 methods we care about, there are 8, I believe, in total. In fact, there's probably more if you some of the more abstract ones. What we've got 4 really cool methods that we can use, and these correspond to CRUD operations on databases. There's only 4 operations you want to carry out on objects. Create a new object, retrieve, get the object, update, and delete. I've simplified things a little bit here for you. Later on we're going to explain that actually put has 2 meanings in HTTP. But as far as you're concerned, and as far as we're concerned for this first 6 weeks, those are the 4 methods, those are the CRUD operators they represent, and that's what they do. So now we've got some methods we can use to describe what we're trying to do. So if I say book 42 and specify get, what happens? Gives me book 42, doesn't it? If I specify book 42 with a put method, it'll update the book. If I specify book 42 with a delete method, delete the book. So you can see how simple this is. And what's amazing, suddenly the penny drops and people realise, actually this is really easy. This is really simple stuff. That's still recording okay, Eric? There's a timer on the bottom. Cool. So, another term which we're going to use over and over and over again. There's a terminology called idimpotent. That's how it's pronounced. Now, anyone been on forums where the person keeps posting the same message? They keep hitting refresh. You've seen this, haven't you? Where they hit refresh and it posts the same message again and again. That's because post is not idempotent. What idempotent means, no matter how many times you carry out the operation, it'll only do it once. If you get a book as the system and you keep saying get, it's not going to change the book, is it? It's just going to keep getting the same book. If you delete the book, when it's gone, it's gone. Yeah, deleting it a second time won't delete it twice. And put If you update a book details, if you keep sending the same update data to the system, it'll update it to the new data, won't it? Once. But post is not idempotent. Post, you can keep adding new records every time you send the information. And I've just explained to you why that's important, haven't I? Because when you start developing these clients, you need to know any non-idempotent methods to make sure you put some mechanism in your client to avoid reposting the same data again and again. Okay, he's back again, Roy Fielding. He's got another idea. Sometimes things don't work on the internet. Yeah, your connection goes down, the server crashes, you forgot to authenticate, the resource doesn't exist. We need a way to communicate to the end user what's happened. Now, the end user as in the client, as in you writing your program. So if something goes wrong, we need an error code. And as luck would have it, HTTP defines about 90 error codes, of which you'll probably use about 6. So in other words, if something goes wrong, you want the web service to tell us what's happened and give us some clue as to why it's failed. So we're going to use Roy Fielding's really important idea number 3. This guy was on the roll. The guy worked on the Apache team, developed the first working on the first web server. Now this is quite a famous guy. There we are. There's 4 useful ones, or 4 So 200 is the normal response code. If your web page comes and there's no errors at all, you get a response code of 200, which basically means we're good. If you get 201, everything's cool, but it's created a new resource successfully. So your post method, if it works properly, you should get a 201 code back from the post. Okay, so you can use this as error checking. 400 is a sort of, we call it the NER response code. The server sort of go, what? What are you on about? I have no idea what you're talking about. And 401 means it was expecting some form of authentication, and you didn't provide the authentication. Okay, so you couldn't access the resource. If you search for HTTP error messages, there's whole documents, pages and pages and pages of these, but we won't need them all. Okay, let's just stop there for a moment. We've just covered 3 really important ideas. We've covered the idea of you can define nouns, resources using URIs, uniquely on the internet. We've covered the fact that you can define the actions you want to take on those URIs through HTTP methods, which already exist. And we've thirdly explained that when things go well or badly, we need to tell the client what's happened. And we can use error messages, HTTP error codes. Okay? So that's really important stuff. Okay, data formats. When we did 205 last year, when you do web page design, it's easy. You return HTML, you embed lots of resources in the HTML, videos and so on, and images. You style it with CSS, and that's easy, isn't it? Well, assuming you pass the module. Unfortunately, HTML is not machine readable. No, it's not easily machine readable. You can read it with a machine. It's called scraping is the terminology they use for it, data scraping, where you actually load the HTML document into a variable and then you try and parse it and break it up into little blocks. It's not very easy, and it's in fact it's horrible. So what we need to do is we need to make sure that the data we get back from our web service is machine readable. In other words, it's really well structured. So we need to have a nicely, tightly structured data that we get back from the web service. So the computer, your client, can understand what it's looking at. You might run out of time on there. Okay. There are 2 possible formats you can use for your data. Well, actually, there's more than 2, but you could use CSV, I suppose, if you really wanted to. But there's 2 common formats we use. One is XML, and one is JSON. You've probably come across XML before, or one of its variants called HTML, where you have opening tags and closing tags, and you have names in tags and so on. It's great, but it's quite bulky, because if you want to put someone's name in, you're wasting more characters with the name tags than you are with the data itself. So if you're on a 3G connection or a GPRS connection, you really do not to be downloading all these tags. It's a waste of bandwidth. What we do is we use another format called JSON, 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 JavaScript Object Notation. And this format is brilliant. It's absolutely brilliant. It works the way we expect it to work. Here's an example. In this example, are you familiar with dictionaries and arrays? Dictionaries and arrays? JSON describes dictionaries and arrays in a really nice format. What we have here, we have an array containing two dictionaries. Can you see that? The array is called books, and you see the little square bracket next to books that says this is the start of an array. And at the end of it, we've got a square bracket at the bottom saying this is the end of the array. Inside the square bracket, you see those little curly braces. That means dictionary. So the whole thing is a dictionary with records and books as entries, as keys. The records key contains an integer value. The books key contains an array which contains two more dictionaries. Is it nesting down a bit now, isn't it? And each dictionary has 3 keys and 3 values. So if you're not comfortable with the concepts of dictionaries and arrays, I would go away and I'd swat up on those a little bit to make sure you understand how they work. But this is if you look how much data there is in there compared to the tags and the non-data. It's very data dense, isn't it? And when you switch your phone on and you go onto Facebook, this is how the data is being transferred backwards and forwards between your phone and Facebook. It's using JSON data. Okay. Quick summary. We need to define any online resource uniquely so we can access it from anywhere. That's the first thing. Second thing is we need agreed methods to perform actions on those resources. Okay? Once we've got those, we can start to build useful programs. And we're going to build these fantastic programs on the server and use them in our clients. Okay, Roy Fielding Geezer. Computer scientist, obviously. He actually worked on the HTTP specification. He was one of the team that defined HTTP back in the 90s. He also co-founded Apache, which is the world's most popular web server. Okay, and his PhD thesis was called Representational State Transfer, and the whole of the REST movement has come out of his PhD thesis. Okay, so basically the whole way the world communicates nowadays is based on this guy's PhD thesis. Okay, that's a good thesis. Okay, so we're going to be right up to the wire on this one today. A web service is a piece of software that makes itself available over the internet. Okay, that's what a web service is. It's a piece of software. It's not a website, it's a piece of software. And it uses open standards to communicate. Why are open standards so important? Yes, so your Windows phone can access it, your Android phone, your iPhone, your desktop computer, they can all access the same web service because it uses open standards. Okay. So, let's quick scenario. We've got an Android app for bookshop and we want to browse books that are on the bookshop. We need to be able to get lists of books, don't we? We need to be able to post orders, delete items from shopping cart, put new items in the shopping cart and so on and so forth. So what you're going to do, we'll talk about next week, we're going to talk about how you design a web service. Not how you build it, how you design an effective web service. But this is an example of the sort of thought process you might go through. And of course, once you've got all these defined, you can then build your code to talk to the database on the server and pull, retrieve, post, delete data from the database. Another term, it's full of terms today, new subject, an endpoint. An endpoint is a combination of the URI, any data it requires, and the method you're going to use. So an endpoint might be to retrieve all the books from the bookshop. So your URI will be bookshop/book/all, for instance. Your parameters will be nothing. There's no parameters to this particular call, and the method will be get. So the term we use is endpoint to define that combination of URI, data, method. Okay, that's what we lump together. So, how does it work? Well, the first thing we have to have is a request. Just like a web page, a web server, just like a web browser uses the request to request a web page, we send a request from the client to our server. And that request is the endpoint. The request attaches to the endpoint. So you've got the method, you've got the URI, you've got the data, you send the request in, which of course defines the version of HTTP and so on and so forth. Your web service, your book web service might say, actually, I could do with some data from somewhere else. And the book web service you're going to be working on this week in your lab talks to the Google Book API itself. So you can insert a book by specifying an ISBN number. That's all. And it will then go off with the ISBN number, pass it to another server as another web service, and it will retrieve all the book details, send it back to the book API, and store the details in the API. So you'll see this in action when you do your lab for this week, how one web service can call a second web service to get something done. And of course, back it comes, book inserted, response code. Yeah, 201. So we're building this web service here, but your web service might talk to other web services, and that's what we call a mashup, where you start combining web services talking to each other. And we're going to use something called Yahoo Pipes for doing some of this work, okay? Which allows you to pull Google Maps and Twitter and all sorts of things into one feed, mash it all together, and feed it into your web service. So it's lots of exciting things you can do once you've got your head around it. And a distributed application is simply a whole load of web services talking to each other. That's what distributed systems are now. So you might have Google Maps talking to LinkedIn, you might have Twitter talking to LinkedIn, LinkedIn might talk to Android devices, might talk to desktop web browsers, and you've got this really complicated system built out of lots of small components. But because they all talk the same language, they all work together. Okay, so how else are web services used? Web services aren't just for you surfing Facebook. Okay, web services are used all over the place. Let's imagine you are a customer and you want to place an order with Amazon. Your Amazon app will have a web service backend to it. It will talk to the web service and place the order with Amazon. Amazon also have a web service which talks to the supplier's web services. So the order then gets bounced to the supplier provides the product. You know, sometimes you get products from Amazon from other suppliers, don't you? It's simply bouncing the request to a different web service. So you can build really complicated systems by just putting the bricks together in different formats. Okay, and we're going to talk a little bit about three-tier architecture. Have you come across this before? If you're from a computer science background, you may or may not have done. If you're from software engineering, you've certainly come across this before. If Kerry taught you, you may have come across this before. Have you done three-tier at all? No? Okay. The idea is you can break your system into three pieces. You've got the presentation tier, okay, which is the bit the user sees. And in our systems, the presentation tier is the Android app or the iPhone app or the web app. Okay? At the bottom end, you've got the persistent tier. The persistence tier is the database, is where the data gets persisted to. And your web service sits in the middle. That's your business logic. That defines how the presentation tier can talk to the persistence. That makes sense? So effectively what you're doing, you're gluing the database to the presentation tier using this web service. And the web service defines who can access resources, how they can access resources, and how the resources are presented back to the user. So there's a whole lot of stuff going on here. And the difference is in a couple of weeks' time, you'll have designed this and you'll have built this. By the end of October, you'll be proficient in building web services. So this week you're going to be playing with the web service, and there's a tool called API-G, which allows you to play with web services and send requests and get responses back and see the data, see the JSON data. Next week we're going to talk about designing web services. In other words, designing up your own web service. And that's the first of the 3 chunks. The next 2 weeks we're going to build the web service. We're going to be doing gets. We're going to build the database. We've got to install the APIs. We've got to configure your creative server to become a web service. And then we're going to build some simple gets in the 3rd week, so you can get resources out of your database. No authentication, just simply accessing data. The 4th week, we're going to do post, put, delete. So you're going to be building web services which allows you to add records, delete records, update records, and so on. And the final 3rd, we're going to talk about authentication. We're going to talk about simple HTTP authentication and digest authentication in week 5, which are pure REST authentication methods. And in week 6, we're going to talk about REST RPC hybrid authentication methods, which are token-based and OAuth. So we're covering a huge amount in 6 weeks. And every week is going to be jam-packed full of stuff to do, all practical hands-on stuff. So I hope you enjoy the module. Now, before we go, I'm not taking the register in the lecture, but there will be Moodle-based registers in the lab sessions.